Okay, we're working on the first review sheet for quadratic equations. We finished the vocabulary and we are going to go to question number 1. Again, class, if you really want to allow these review sheets to help you get ready for the test, you've got to attempt the questions first and then check the answers. If your answer is right, you're good. If the answer is incorrect, then watch the video to remind you or to clarify what you're supposed to do. This section says show your work in the blank space or lines provided and write your final answers in the box. Alright, so we've got an equation where we're supposed to find the solutions or zeros of the following equations. This is intercept form, so intercept form we're using the zero product property. That means we take every term that has an x in it and try to figure out what that x value has to be to make it equal to 0. So this one's pretty easy. We've got two binomials. We've got x minus 3. We want to try to get that equal to 0. And x plus 7, try to get that equal to 0. If either one of these binomials is equal to 0, then the whole thing on the left changes to 0 because we're going to be multiplying by a 0 value if either one of these is 0. And that makes our equation true. And if the equation is 0, then we know we're finding an x-intercept or a solution or a 0 because we know that y is equal to 0 when we're on the x-axis. So in this case, we add 3 to both sides and we end up with x equals 3. We subtract 7 from both sides and we end up with x equals negative 7. So our answers here are negative 7, 3. Let's try the next one. Now, I know a few students look at these and they think, I've got to do something with the 6. I've got to do something with the negative 4. Not when you're finding solutions. When you're finding solutions, you can just ignore that a value, or sometimes we can call that the GCF of the whole equation. You ignore it. Don't try to put it back in. Just leave it out. Because again, that number is irrelevant. If this binomial changes to 0, then negative 4 times 0 times anything gets us to 0. So we ignore that. Let's find out what changes x plus 14 to 0 and what changes x minus 2 to 0. In this case, you subtract 14 from both sides. You get negative 14. And here we add 2 to both sides and we get positive 2. So our solutions, or we call them zeros, or we can call them x-intercepts, are going to be negative 14 and 2. Okay, number 3 gets a little bit trickier, but not too terrible. It's just Algebra 1 skills. We've got to find out what changes this binomial to 0. So what changes 2x plus 1 to 0? And what changes x plus 6 to 0? Again, you ignore this 2. It does not affect the problem at all. What's going to change this binomial to 0? Or what's going to change this binomial to 0? We got to do algebra here. We got to subtract 1 from both sides to move the 1 to the other side. And then we're going to divide both sides by 2. The 2's can be canceled because 2 over 2 is 1. And we end up with x equals negative 1/2. And then this one, just an easy one. You subtract 6 from both sides. You get x equals negative 6. And just think about this class. Pretty simple. Well, what number is going to change x plus 6 to 0? It's going to be the opposite of 6, which is negative 6. So now we've got two numbers here as our solutions, negative 6 and negative 1 over 2. If you wrote that as negative 0.5, that would also be just fine if you used your calculator to solve this one. I'll circle this one too since the other one was circled as well. Okay. Change of thought now. We're still finding solutions or zeros, but now we have a standard form quadratic. Now we just covered this property in the last couple days. We covered it in the beginning of the unit as well. We've got to keep reminding ourselves of this to save us some time. I want you to make a note here on this one, in the margin. So it's kind of put it over here somewhere. I want you to note no C value. Here is a standard form quadratic with no C value. That means factoring it to find the solutions is simple. All we have to do is find our GCF. Start with 3. 3 goes into 15. Notice this 0 can just stay over here. Of course, whenever we solve, we always set the equation equal to 0. The first 3 equations were all already equal to 0. So it's already set to 0 for us. What's our GCF? Well, the smallest number is 3. 3 goes into 15. And a value is positive, so we leave that as positive. But also, class, we have a common variable. With no c value, you will have a common variable. In this case, it is x. So now all we have to do is factor out the 3x. 3x times x gets me back to 3x squared. 3x times 5 gets me back to 15x. And my factoring is done. And all I have to do is find, I'll change color so you see this, what is going to change the first term to 0, which is what is going to make 3x equal to 0, and what's going to make x plus 5 equal to 0. Either one of those will change the whole thing to 0. Well, this is just simple. 3 times 0 gets us to 0. And then subtract 5 from both sides. You got x equals negative 5. So our solutions are negative 5 and 0. Let's do another one just like it. Again, if you would please, write in the margins, you don't forget. There is no c term here. I don't have to go through a whole factoring process, because when there's no c term, we have a common variable in there. So let's find our GCF. 6 is our smallest number. 6 happens to go into 18 3 times, and because a is negative, we're going to pull out a negative GCF. So here is our GCF of negative 6. Oops, I apologize, I'm skipping this as well. We got a common variable as well because there's no c term. So our GCF is negative 6x. Negative 6x times x gets us back to negative 6x squared, and negative 6 times negative 3 gets us to positive 18. So negative 6x times negative 3 is positive 18x. And now we've got our two parts. What's going to make negative 6x equal 0? What's going to make x minus 3 equal to 0? Well, in this case, add 3 to both sides. You got positive 3. In this case, it's always going to be 0. Negative 6 times what number gets us 0? It's 0. So our solutions are 0 and 3. And then last one. Number 6, we're still asked again, what are our solutions, or our, what do they say, solutions or zeros? You can also say x-intercepts. You could also say roots. And roots make sense here because this looks like a vertex form quadratic. Class, we have learned you solve vertex form quadratics by square rooting. So in this case, we're going to use our square root rule. So I've got x minus 5 squared equals 9. We're going to square root both sides. I've got no a term here, so I've already have my squared term by itself on the left side. That means I can square root, and when I square root the right side, it ends up being plus or minus the square root of 9. Square root cancels the square because they are opposite operations. We've got x minus 5 equals plus or minus the square root of 9. We're going to move the 5 over now, and that's going to change to positive 5 on the other side of the equal side, plus or minus the square root of 9. You're going to get two solutions here. You've got 5 plus the square root of 9 and 5 minus the square root of 9. You put those in your calculator, you're going to get 8 and 2. 8 and 2. Let's run that just real quick. So just to remind ourselves how to do this. So 5 plus square root of 9. Make sure you close the parenthesis if your calculator adds a parenthesis to your square root. And then press equal. And then you see it's 8. So our solutions are 2 and 8. Alright, that ends question number 6. We'll start up again in the next video, question number 7.